Okay, so this is a follow-up video on Advent of Cyber Day 10. I'm gonna try and explain a bit more what game hacking is all about and how you should really think about it. This is gonna be a very simplified version, but I tried to draw a game on the left side here. It's called The Man Against the Evil Killer Bird. Okay, and this is the thing that the man have a health bar here at the top. And that health bar got some HP, and we're just gonna call it HP. This is a very large font, and it's gonna be black so we can see it. Maybe it's a bit more sizable. We just put it. So the HP for health points is gonna be the health point bar for this man here below, and we're also gonna create one for the evil monster of Doom, or whatever name is. Gonna make this. Orange. So the thing is now that if you're gonna hack the game, if you have access to the game, which is in turn what you need to have, then it should be running on your computer, for example, or you should have a program running on another computer that you have access to. Ideally, the program should be running on your computer, either in your browser or just running on your computer. Everything you run on the computer store data, and that data stores in your RAM. So the random access memory, which is what many people just refer to 16 gigabytes or 8 gigabytes or 32 gigabytes of RAM, which is the memory of the computer, the short-term memory, you can call that. So that short-term memory of the RAM stores all different kind of values. Now we can assume for now that the value of the health bar of this person here is stored in that local address. Now, of course, we need to verify that, and somewhere you should use a program. As you noticed in the Advent of Cyber Day 10, we use the program to probe the memory to look for value. So it's assuming now the value of the HP bar, let me just make a number, is 100. We don't know that. Sometimes game doesn't represent the health bar by numbers, but just by visual representation, which is easier for users to see in many cases. Now we know that the address of that, because I tell you it is, but if you didn't know, we would have to probe for the number 100, but we couldn't do that because how many numbers of 100 can we find in the memory? A lot, okay? Just trust me, a lot, hundreds of thousands. So what you could do is go ahead and create an initial search, and the initial search, let me just write it there, make it a bit bigger so we can see it. The initial search is gonna give us, let's just assume 5,000 results, just to say something. Then what you're gonna do now is you're gonna take some damage, for example, and that damage is gonna bring the number of 100 down to, let's say, 90, and then you're gonna do a new search. But you're gonna do a new search on the results you have, because all the results you have so far contains your HP. You know that because the way you search is saying anything that is consistent of value, I want that right now, because your health bar is not moving, it is consistent. So that is the way you need to think, that the memory is consistent, the HP is consistent, it doesn't change, right? So you have these 5,000 results. Next time your health bar is now, let me just say HP to 90, you're gonna do a second search, and the second search you're gonna say, you say anything any lower than, okay, than the initial, any lower than the initial, and that's gonna give you, let me just assume we're gonna give 35 results. Now with this amount of results you'll be able to see what kind of values are stored by the addresses. Maybe you can just say that is the one I want, and then you can either do, change it, the actual value, depending on the editor you have. You can change the value, or you can freeze the field. Freezing the field basically means that you're gonna keep a shield over. So I say no. You say no to the program to change that address. So now when the evil killer bird of Doom tries to give you more damage or take more health from you, then it's just gonna work because it's not gonna rewrite the actual lower memory to lower values to the memory. The code behind all of this, could be like some if statements, say like if player HP is lower than or equal to 0, sorry, not that, is lower than or equal to 1, 0, then the player dies, or something like that, right? That's the code. So that could be the actual code, and as long as it doesn't get that low, it's and that's the thing. This player HP is a variable, right? And that variable could be created somewhere like as an integer value, let's say 100, like that, just with the 100, and that is the variable. When you compile the program, it will be stored in the memory, and then you can access it by searching for the actual value. You cannot search for the name of the variable. That doesn't work like that. The name of the variable is just for UIs only, human readable code. The actual name of the variable is 0xAAA in this particular case. Now it's just a simplified version of a hexadecimal address, but all addresses in the memory represented to you in a program is in hexadecimal. And all hexadecimal addresses have a value. So it's basically just a value key pair. So you call it key value in programming, but in memory you call it address value. And it doesn't really matter which terminology you use. So the address is always this one, and the value is always this one or that one, and so on. Let me just choose another color, because that is really difficult color to read. So we could just say this one or that one. That's always the same. The address is always one of those, and the value is always one of those, right? So this is how it works. Narrowing down the results, going back to result 35 now, right? You can guess. So now you have different kind of things you can do. You can alter you can alter 35 to 100. You can freeze the address that contains the value of 35, and you're gonna do that just to give methods here. The program will not be able to change the value, which will keep your health bar consistent, and it will now be a consistent value one more time that you can search for. But you don't really need to do that. In the program on TryHackMe, it was a really bad program. The real program to use is something called Cheat Engine. That is a fully fledged program that can hack computer games. That is a whole other chapter of computer gaming hacking. Now, I hope in some way that this video with the evil killbird of doom and my poorly, badly drawn results here going to give you some sort of idea of what's going on and a better understanding of how this works. So just want to say, really happy that you watched the video. If any questions, just leave the comment below. I'm going to get back to them as soon as I can. See you again online.